This is for Specialist Maths. It comes out of VCAANH Northern Hemisphere 2018, question number 9 from exam 1. So I've got a double angle formula here, and I've got to show that this is the case. So the cot of 2 theta is equal to 1 on the tan of 2 theta. And looking at my formula sheet, the double angle formula for tan is this. So cot 2 theta is A will equal 1 minus tan squared theta on top of 2 tan theta, which means 2a tan theta equals 1 minus tan squared theta. Move everything to the left. Tan squared theta plus 2a tan theta minus 1 equals 0, and that's what we had to show. In the second pass, I've got to show that tan, so if I considered this to be p squared plus 2ap minus 1 equals 0, where p equaled the tan of theta, then I could use the quadratic formula, and the quadratic formula would be p equals, so a equals 1, b equals 2a, and c equals negative 1. So minus 2a plus or minus the square root of 2a squared minus 4 times 1 times minus 1, which gives all over 2, which gives me minus a plus or minus the square root of 4a squared plus 4 all on 2, which is minus a plus or minus 2 root a squared plus 1 all on 2, which is minus a plus or minus the square root of a squared plus 1, and that's the correct answer. Hence, show that. Okay, I know from above that the tan of theta is equal to minus a plus or minus the square root of a squared plus 1. And I know the cot of 2 theta equals root 3, therefore a equals root 3. And if I had the cot of 2 theta, 1 on the tan of 2 theta equals root 3. So the tan of 2 theta equals 1 on root 3. 2 theta will equal pi on 6. Therefore, theta equals pi on 12. So since I know that a equals root 3 and theta is pi on 12, the tan of pi on 12 is going to be minus root 3 plus or minus the square root of root 3 squared plus 1, negative root 3 plus or minus 2. And since I'm in the first quadrant, I want the positive square root, which will give me minus root 3 plus 2, or 2 minus root 3, which is what I had to show. Okay, the next bit is part B, find the gradient of the tangent to the curve. Therefore, I want dy dx given x equals pi on 12. So if y equals the tan of theta, then dy dx equals sec squared of theta, or 1 on cos squared of theta. So I want the gradient to equal 1 on the cos of pi on 12 squared. So I know that the tan of pi on 12 equals 2 minus root 3. So this is pi on 12, then 2 minus root 3 over 1. So this is the square root of 2 minus root 3 squared plus 1 squared. the square root of 4 minus 4 root 3 plus 3 plus 1, 8 minus 4 root 3, 2 square root of 2 minus root 3. So therefore the cos of pi on 12 will be 1 over that, 1 on 2 square root of 2 minus root 3, which means that the cos squared of pi on 12 equals 1 on top of 4 times 2 minus root 3, which means 1 on the cos is going to be 4 square root of 2 minus root 3, and that's what the gradient is going to equal. And then lastly, the solid of revolution. So I've got tan of theta, solid, so I'm rotating it between pi on 12 and pi on 3, and this is my region, and it's being rotated about the horizontal axis. So the volume is going to equal pi times from pi on 12 to pi on 3 of y squared d theta, which will be pi on 12 to pi on 3 of tan squared theta d theta, tan squared theta equals sec squared minus 1, and I want to use that because I can integrate sec squared. So sec squared theta minus 1, so that's the integral from pi on 12 to pi on 3 of sec squared theta minus 1 dx d theta, which is equal to pi tan theta minus theta from pi on 12 to pi on 3, tan of pi on 3 minus pi on 3 minus tan of pi on 12 plus pi on 12. Tan of pi on 3 is root 3 minus, that's pi on 3, so 4 pi on 12 plus pi on 12 minus 2 minus root 3. I know that because that was given to me way over here. Which equals pi outside of root 3 plus root 3 is 2 root 3 minus 2, and that's minus 3 pi on 12, which is pi on 4. Units cubed will be the volume of revolution.